Alright, so in this problem I have x minus 3 squared is equal to x squared. So to solve this, I want to find the value of x. So for my solution, first start with x minus 3 squared is equal to x squared. Then I'm going to subtract x squared on both sides. So now I have x minus 3 squared minus x squared is equal to 0. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x minus 3 and b is x. So I have x minus 3 plus x times x minus 3 minus x. And this is equal to 0. So all we have to do is simplify this. So for x minus 3 plus x, I'm going to add these two x's. So now I have 2x, and then I have minus 3 at the end, times, for x minus 3 minus x, cancel out the x and negative x. So now I'm left with negative 3 is equal to 0. So now, if I go ahead and distribute this negative 3, negative 3 times 2x is negative 6x. Negative 3 times negative 3 is positive 9 is equal to 0. So I subtract 9 on both sides. I get negative 6 is equal to 9. Sorry, negative 6 is equal to negative 9. And then I divide both sides by negative 6. And I get x is equal to 3 over 2. Now another way I can do this is, I'm actually going to write this up here. I have 2x minus 3 times negative 3 is equal to 0. This time I can actually divide both sides by negative 3. So I get 2x minus 3 is equal to 0. So 2x is equal to 3, and x is equal to 3 over 2. So that's two different subparts of solving this, and 3 over 2 is my solution. Alright, so in this problem, I have x to the power of x is equal to 2 to the power of 2048. So to solve this problem, I obviously want to find the value of x. So for my solution, first start with x to the power of x is equal to 2 to the power of 2048. And now I'm going to rewrite 2048 here as 2 times 1024. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So in this case, a is 2, m is 2, and n is 1024. So if I rewrite this in this form, I get 2 to the power of 2 to the power of 1024. And remember, this is equal to x to the power of x. Now, 2 to the power of 2, and that's equal to 4. So I have x to the power of x is equal to 4 to the power of 1024. Now, I'm going to repeat what I just did again. So 1024, that's equal to 2 times 512. So now I have x to the power of x is equal to 4 to the power of 2 times 512. And again, this is equal to x to the power of x is equal to 4 to the power of 2 to the power of 512. 4 to the power of 2 is 16. So I have x to the power of x is equal to 16 to the power of 512. Now 512 I can rewrite as 256 times 2. So I have x to the power of x is equal to 16 to the power of 2 times 256. Now, this, I'm going to do the same thing again. So I have 16 to the power of 2 to the power of 256. And 16 to the power of 2, that's equal to 256. So now I have x to the power of x is equal to 256 to the power of 256. And if I have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So in this case, x is equal to 256. And to test this, I'm going to plug this in. So I have 256 in for x. So I have 256 to the power of 256 is equal to 2 to the power of 2048. And remember, we just wrote all of this, so we know that 2 to the power of 2048 is equal to 2 to the power of 2048. All right, so in this problem, I have 2 to the power of x minus 1 is equal to 3 to the power of x plus 1. So I want to find the value of x here. So for my solution, I first start with 2 to the power of x minus 1 is equal to 3 to the power of x plus 1. Now, I'm actually going to take the log on both sides. So now I have log 2 to the power of x minus 1 is equal to log 3 to the power of x plus 1. And if I have something in the form log a to the power of b, I can move this exponent b to the front. So this thing equal b times log a. So in this case, I have log 2 to the power of x minus 1. I can move x minus 1 to the front. And log 3 to the power of x plus 1, I can move x plus 1 to the front. So now I have x minus 1 times log 2 is equal to x plus 1 times log 3. Now, if I distribute these two, I have x times log 2 minus log 2 is equal to x times log 3 plus log 3. Now I'm going to subtract x times log 2 on both sides and add log 2 on both sides, subtract log 3 on both sides. So then these two cancel out, and I have negative log 2 minus log 3 is equal to x times log 3 minus x times log 2. Now if I factor out x from here, I get x times log 3 minus log 2 is equal to negative log 2 minus log 3. If I divide both sides by log 3 minus log 2, I have x is equal to negative log 2 minus log 3 over log 3 minus log 2. Now, if I multiply both sides by negative 1, I get x is equal to log 3 plus log 2 over log 2 minus log 3. So this is my answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 2 to the power of x squared is equal to 3 to the power of x. And what I'm first going to do is I'm going to rewrite 2 to the power of x squared as 2 to the power of x to the power of x. So if you guys already didn't know, if we have something in the form a to the power of m to the power of n this is equal to a to the power of m times n. So as you can see here, 2 to the power of x to the power of x, this would equal 2 to the power of x squared, because x times x is x squared. Now this is equal to 3 to the power of x. And as you guys, if you guys already did notice, a solution, an immediate solution actually, is x equals 0. Because if we plug in 0 for x, both of these terms would equal 1, right? Because anything to the power of 0 is 1. However, that is not the only solution. So now I'm actually going to take the power of 1 over x on both sides. And remember, a to the power of m to the power of n is equal to a to the power of m times n. 3 to the power of x to the power of 1 over x. This is going to equal 3 to the power of x times 1 over x. And x, any number times its reciprocal is simply just 1. So this would just be 3. This is equal to, again, x to the power of 1 over x is 1. So this would just be 2 to the power of x. So now we have 2 to the power of x is equal to 3. Now I'm going to take the natural log on both sides, so ln on both sides. And an important property of logarithms is that, let's say we have ln to the power of ln of a to the power of b. For this, we can actually move the exponent, which in this case is b, to the front of the logarithm. So this would actually equal b times ln a. So in this case, we have ln 2 to the power of x, and we can think of x as b and 2 as a. So we can actually move this exponent x to the front of the logarithm. So this would be x times ln 2 is equal to ln 3. Now I'm going to divide both sides by ln 2. So then these two cancel out, and I'm left with x is equal to ln 3 over ln 2. So this is our answer.